Hi everyone. We shall wait for some time and then we shall start. We shall wait for one more minute so our participants can join. The viewers are still joining, so let's wait for them. Okay, last few more seconds we can wait and then we can start. Okay, I guess we have a good amount of viewers today. So, hello everyone. I am Mohammad Ali Thara and I would like to welcome you all in today's webinar on over the air firmware update. Wondering what is OTA? Do you get an update on your mobile phone? It is nothing but an update over the air. So, this update can include firmware or software or maybe both. In this session, we will be going through these following points. Let me share my screen. Okay, I hope my screen is visible. So today's agenda is what is firmware and why do we need firmware update? Methods of firmware update, pros and cons of both manual and OTA firmware update, flow and process of OTA firmware update, OTA update types and their methods, and the last point we shall cover is OTA data partition and security measures. Before we dive into the topic, I would like to know how many of you are familiar with OTA firmware update. Please respond to the poll which is going to come next on your screen. So here is a poll on your screen. You can respond yes or no. We shall wait for 10 more seconds. We are still getting the response. Okay. Yes, so we do have a response with us, and I can see that most of you have responded yes. Few are with no, but yes. So this webinar will be a refresher, those who know what OTA firmware is, and not an issue if you don't know. This webinar will help you to understand it in a better way. So while developing an IoT device, one of the most difficult problems to solve is how to update the firmware on the device that is in the market. So once the device is deployed, firmware update plays a critical part in its lifetime, particularly when the device have a long lifetime or suppose the device are deployed in some remote areas or in inaccessible inaccessible areas, or where manual intervention is cost prohibitive, or sometimes it's very difficult to update the firmware there. So why we actually need this firmware update? The need for the firmware update may be to fix bugs in software, to add new functionalities, or to reconfigure the device. So while we are having firmware update process, we must ensure one thing, that is the firmware image is authenticated and the attempt to flash malware image is prevented on it. The second part we should ensure is that the firmware image can be confidentially protected, so that attempts by any advisory to recover the plain text can be prevented. So obtaining the plain text binary is often first steps towards the attack of on your device. So there might be some who are new to this field. So for them, let's first understand what firmware is. Firmware is basically a set of instructions needed for certain devices to perform the task that they were made for. A bit difficult, I guess. So let's make it simple. It is nothing but the programming that is responsible to run the hardware. So unlike software, firmware is not created to perform specific functions on the hardware. Rather, it is used to carry out the core functions of the hardware. So most of the devices that we are using today can be referred to as a computer-like system on its own. The manufacturers of these devices make continuous improvements to the programs, which is firmware for us, that is responsible for efficient running of the device. But why do we need firmware update? As firmware carries out integral function of hardware, firmware update brings some alterations in the program, so which are necessary to enable the corresponding device to operate proficiently, as well as to fix the bug or for better security. So to update a device firmware, the device user or the customer just needs to install the update that is developed for his particular device. But when we are updating our firmware, there are some upsides, which is when we install the most recent firmware on our device. So let's look the what are the upsides of updating the firmware. A firmware update will upgrade your device with advanced operational instructions without needing any upgradation in the hardware. So by adding the firmware, you will be able to explore new features that are added to the device and also have an enhanced user experience while interacting with the device. Even a firmware update will optimize the performance of the firmware or device driver, enhancing the performance of the processor. Even it will have a significant impact on the improvement of instruction times, or out of order execution, or maybe branch predictions, or the execution time. And optimizing device driver will also help you quickly decode algorithms and thus utilize the hardware at an optimum level. So we all know that logical operations of most of the appliances we use resides in the EEPROM, that is electronically programmable read-only memory, which can easily be upgraded in case of firmware update. So after updating the microcode, all the device peripherals will work better together by eliminating the delays and thus enhancing the overall performance. Okay, I could see there's one question for us. So the question is, can we fix stability and performance issue with firmware change? Yes, of course. A few issues may have developed in the system over time due to faulty software or firmware changes which were updated previously. So these issues can be handled with firmware updates by providing regular service fixes. Going ahead, we have like two types of firmware update. One is manual firmware update and another is the OTA firmware update. Let's first see what is manual firmware update. So manual firmware update were the only option before the introduction of OTA technologies, and they are still used in certain situations. Typically, manual updates involve downloading the new firmware to some storage device such as hard disk or flash drive and then connecting it with your working device. So device usually needs to be taken apart, it should be reprogrammed, then reassembled, and again it should be restored so it can function again. Obviously, there are some pros and cons for the manual firmware update. Let's see what are the pros of manual firmware update. The most obvious benefit of manual firmware update is that nothing can be rolled out before the end user is ready. So for this, the owner or the operator who is handling the device or the customer should be ready to accept the change. This can be crucial in situations where the device must always operate in a stable and in a predictable manner. The another benefit or pros of manual firmware update is uh, in certain situations, for example, when a device refuses to turn on or you have a weak or non-existing internet connection, then your manual firmware update is the only option to overcome the OTA firmware update. But there are again cons of manual firmware update. The most obvious disadvantage of manual firmware update is having to retrieve and update the device by yourself. So this will require finding a maintenance window when the impact of downtime won't be great. So you can see a device needs to be packed, shipped, then unpacked, plugged, then upgraded, then you have to repack it, then reship it to the user again. So in addition, manual firmware update aren't scalable, meaning that the device may be difficult or impossible to update once they are out of your hand. So if the device is too complicated for the end users to do the update by themselves, they may have to bring the device to you in order to get it serviced. Before we move further, I would like to know like how many of you have done any kind of OTA firmware update process. Any one of you have implemented in your career recently. So please respond to the poll, which is going to be on your screen. So here is the poll. Please respond whether you have implemented OTA or not. Okay, so we are getting the response. We shall wait for a few more seconds. Yes. Okay, I could see the result here. Okay, I could see most of you have not implemented any OTA update process. Not and worry, we will look into it how it is done. Continuing from my previous slide that we had two types of firmware update. So second firmware update is the OTA firmware update. So over the air firmware update involves remotely updating the code on the embedded device. So the update is delivered wirelessly, so it is called as over the air, and it is sent directly to the device without the need of any underlying hardware in between. So OTA updates are actually delivered through cellular data or high speed internet or maybe Wi-Fi. Before we dive inside more, let's understand what are the pros and cons of OTA. So the biggest benefit of OTA IoT firmware update is that you can continuously add new features, you can fix bugs and improve your product behavior even after the device is in the end user's hand. Apart from this, you can try out experimental features with A/B testing or sending different versions to different products for a specific group of users. For example, we call it as a beta version. A test version can be sent to a particular group of users. If it goes good, if it works well, you can deploy it to other devices as well. The another advantage you can say is OTA firmware update also generally save on cost. You can manage the firmware across your fleet of device from seamless unified interface. So without having to recall the device, the vendor can update the firmware on the device to make sure that they are up to date and the last known problems are patched, are solved in this new firmware update. So by using OTA update, the need to in-person maintenance is also eliminated, thereby cutting the costs significantly and removing the need to provide the field engineer or service engineer. So this can again reduce your operational cost as well. And the last is like OTA update can be used to add features that were not originally included in the devices, so thereby increasing the value of the device. Of course, it can be an paid service by the manufacturers. They can include the additional features in the device which was not discussed or which was not promised to be delivered. So they can have a paid upgrade and they can add this functionality in the device. Yeah, but again it has some cons over manual firmware update. So while they are highly convenient for both IoT manufacturers and users, OTA firmware update do have some drawbacks. For one, they require the device to be working and it should be connected to an internet. In addition, the device needs to be shut down and restarted in order to complete the update, which can be a problem for any scheduled of the update. And OTA update also fails at a higher rate than the manual update. So in general, getting software to update itself is a difficult problem. In some cases, the update file will fail to download to the target file. Another example is if during the update the device crashes or suppose it turns off. So this can be again a difficult situation to come out of. Okay, so we have another question with us. The question is, can we forcefully update the firmware of a device without user approval? Yes, of course, there can be a forced update, but again, it can be of two types. Like we can schedule the update to install when the device is powered up next time. Uh, or the second way is like after a certain number of retries, we can force the user to update the device before using it. Moving ahead, how actually OTA works, that is over the air, how it is working, let's understand it. The OTA process is self-explanatory in that it delivers updated software wirelessly or over the air. So these updates are actually distributed over Wi-Fi or mobile broadband or sometimes Bluetooth using a function built into the embedded device operating system, or even through a special OTA app that is given a root access. The update goes out to all the designated embedded device from one central control panel. And we have here again two ways in which the update can be applied. For example, the first way is accepting the update by the end user, which we call it as a manual update. And the second way can be the pushing the update automatically, I told earlier. So this we call it as an automatic update. We will look them in detail in the upcoming slides, but before that, let's see what are the components of an IoT device firmware. So IoT device transmit and receive data over the internet, and currently most IoT devices are connected wirelessly. So when designing your next IoT device, one very important aspect that must be taken into consideration is the process of updating your firmware of IoT device. So we are familiar with the idea that firmware is written once to interface with the hardware and it is rarely changed. But this was in part due to the idea that most devices were not designed actually to be connected to an internet. This was the previous thinking. However, with the current rise in the IoT development and deployment of the device, the definition of firmware should be revisited. So let's begin by exploring the different components of an IoT device firmware. In typical, you will come across the following components of the firmware. I have tried to collect few. So the first can be the application specific program. This is the main program of your very specific application. This is where all the different components of firmware will be tied together to make a nice flow. The next component we can have is the wireless connectivity. So it can be a Wi-Fi or Bluetooth, so which is highly dependent on the wireless connectivity protocol used. And most wireless microcontrollers come with supported protocols which can be very easy to use. It can have very easy APIs, like for example which I oftenly use is ESP32 microcontrollers. The next component we can have is device driver. So this can have external sensor drivers, likely written by the developer of IoT device to work with any external sensors used along with the microcontrollers. So if you want to collect the temperature in a room, for example, what you will do, you would have to use a temperature sensor, right? And then you need to write a driver to sample the data out of that sensor. So this all comes under the device driver section. Another component we can have is the cloud connectivity. So the APIs and SDKs that are most likely provided by the cloud service provider to interact with the cloud. For example, um, an example is connecting to an IoT MQTT broker, receiving commands, etc. The next component I have tried to explain is the provisioning. So each IoT device will come with some default settings that need to be changed to the user specific settings. For example, the configuration of access point of Wi-Fi router with the SSID and the password passed to the microcontroller that is to be connected to the internet. The next component can we can have is the OTA firmware update. So this is one important component that should be included in your development cycle. Yes, I'm repeating again, this is very important component that you should include in your development cycle, as it will enable your IoT device to be updated via internet without having to physical interface with the device. The last component is very important, since it is actually the crypto utilities. Since the microcontrollers uh, must connect to the secure cloud, the controller must be able to authenticate itself by signing and decrypting messages from the cloud. So most microcontrollers that are IoT enabled have their own libraries, and they have a support such as AES, SHA, or random number generator, that is RNG, or memory encryption, decryption, etc. So all we can have it under the crypto utilities. These components are the fundamentals of every IoT device, although there may be more or less depending on your specific applications, but I have tried to collect few of them here. So as we saw that we have two ways of updating a firmware. So one is manual and another is OTA. But how is the update flow? Let's first see the manual firmware update flow method. So it is very simple. We all use it. Like suppose we have a C source file. It can be a .cpp or .c source file, and the compiler compiles it to give an object file that is .o file. Then linker links it to get an executable that is .bin file, and then it is flashed on the controller. So programming any microcontroller device begins with a simple C++ program on your host computer or maybe laptop or PC, whatever you're using. And then a compiler is used to build that into an executable binary file, which we call it as .bin file. Then a microcontroller specific toolchain is used to upload the firmware binary file to the controller. So you can upload it using any wired connection, like example we can have it as USB. But this approach is mostly used for debugging and developing. However, it can be harder to update the firmware binaries after the devices have been built and they are deployed into the market. Especially this is true for the minimum viable products, that is MVPs, where constant improvement are needed and the feedback from the user is necessary, that we need any change or we need this bug to be fixed or this is the new functionality we need to add. This is why OTA firmware update are an important feature that will greatly benefit the iterative development cycle. Similar is the OTA firmware update flow. So again here you can see that mm, programming any microcontroller device again begin with C or C++ program on your host or laptop or PC, and then a compiler is again used to build the executable file. The difference is that this .bin file is uploaded on the server, and then the admin sends the notification to the IoT device that there is a new firmware available and it is to be downloaded to your microcontroller. We shall look it into the update process. Generally the firmware update process looks something like this. So we have like 4 steps. Step number 1 is the binary files are uploaded to a server and URL is obtained to point to the binary file. Then the second step can be a notification is sent to the IoT device that new firmware is available to download and the URL for the firmware is provided there. Then we can have a third step as the IoT device will download the firmware using HTTP. So the firmware file which is downloaded should be saved in a different partition. We shall look again into the partition, data partition, where the downloaded files should be saved and how it should be saved in the upcoming slides. And the step number 4 can be the IoT device will check the authenticity of the binary file and it will start to load in the newly downloaded firmware. So you can see that new firmware command is first received, then the firmware image is downloaded from the server, then its authenticity is checked, and then it is boot into a new firmware image. There a few functionality is tested. If that test cases are passed, then new firmware image is committed. Else if it fails, then you have to revert to the previous working firmware. So actually a fallback mechanism should be in place after step number 3 and 4. In case the firmware file is corrupted during the download, the IoT device should not load in the new firmware or it should free the used resource. Uh, let's look at an example of using ESP32. So the OTA update should also take place outside of the normal operating conditions of the device. For example, if the IoT device is operating an important actuator that opens or close a gas door, then the update should take place in the background while the main tasks are running and they are not interrupted in between. So this is why using a real-time operating system, that is RTOS, is advised, where multi-threading can be used to deploy multiple tasks running independently. I've just given an highlight to RTOS. I'm not covering any part here. It can be a separate topic or a separate webinar. So, but RTOS can be a very good benefit here to use. Now, OTA update again are divided into two types, as I told earlier. So when it comes to the perspective of the edge device and end user, the OTA updates can be categorized into two main methods. The first is automatic OTA. So these types of updates are deployed by the IoT device manufacturers themselves, and they are installed automatically on the device depending on the configuration settings, such as automatic update, enable flags, or scheduling it after some time. Any kind of way can be used. For example, the Android or Linux critical security patches, or remote fleet management, or supply chain, etc. The next type is the manual OTA update. So for the update that are not usually mandatory for the users, such as operating system feature update, or it can be an UI update, there the manual OTA updates are entertained. So in this case, the end user needs to launch the update checker to check whether there is an update, and opt in to install the update if it is found that there is an update. So sometimes the firmware of IoT device will notify the user of an available update, provide him the choice whether to install it or to skip it. For example, we can see with our smartphones as well. So if we have some app, so if there is an update to that app, we get a notification that there is an update. It is up to us. It is not mandatory that we should install it or we should update it. We can even skip it. So another example is like Linux kernel upgrade, or UI update, or feature updates, etc. The OTA updates can be deployed through the internet, a local network router, a dedicated gateway device, or even it can be deployed by connecting to the individual hardware wirelessly. So mainly there are three major methods of OTA updates. Let's look at what are they. First is the edge to cloud OTA update, that is E2C. Next is the gateway to cloud OTA update, that is G2C. Third is edge to gateway to cloud OTA update, that is E2G2C. Now, what is edge to cloud update? That is E2C. A connected device with a built-in microcontroller or a microprocessor receives OTA packages from the remote server. So the package can include the upgrade to both the microcontroller or processor's underlying hardware capabilities, which we call it as firmware over the air, that is FOTA, and updates to the application running on them. For example, we call it as software over the air. So Google Home, Apple Siri, Nest thermostat, these are some of the examples that use the E2C update method. And the advantage of E2C OTA update is it allows the update of individual devices, making the entire fleet secure from corruption if the update goes wrong in between anywhere. But again, it has disadvantages. So here the individual update may take a lot of time if the fleet is very large. It should also be made sure that the correct device or devices are deployed are selected to deploy the update, considering their working state. That is, if the device is in middle of performing any critical task, which I told earlier, an example of actuator opening and closing the gas door, so it is into a critical task, so the update should be deferred regardless of trying to force the that is to be installed on it. The next method is gateway to cloud update, which is G2C. Here, a system featuring an internet connected gateway, for instance, a telematics system, which manages a set of local device and receives update from remote cloud-based server. Then these update include new versions of installed software application or firmware, the app's host environment, and or the gateway device firmware. So in this case, the connected device are actually not updated, rather the gateway itself is updated. Some of the devices that use G2C OTA methods are ATMs, remote energy monitoring system, and other banking and financial services. So these OTA update methods improve the security of the system as the device are protected from outside attacks. The advantage of G2C OTA updates are, since it's the gateway that is being updated and not the sensors or the sensor nodes, the gateway can stay up to date, handling the communication and processing tasks. But again, it has a disadvantage. So when it comes to the security or reliability, the gateway itself provide a single point failure, which can render the whole system unusable if OTA update goes wrong in between somewhere. The next disadvantage is if the gateway cannot recover from a failed update attempt, the whole system again can fail permanently. And also, it can never be certain that when the gateway device will be free for installing the update, since it manages multiple nodes and handling data coming from them continuously. So when the update process is executed, it can certainly be expected to cause some disturbance to the functionality of the system in this G2C OTA update. Next is edge to gateway to cloud update, that is E2G2C. So an internet connected gateway acts as a dispatcher. It downloads from the cloud based server and then dispatches to the another gateway or edge. In this case, the IoT device should be able to execute the update by themselves. So in this actually this method is used by devices such as field-based sensors such as temperature sensor or humidity sensor or weather sensors and other industrial management sensor systems. So the master device is capable of downloading and distributing update corresponding to the slaves or some other devices in the network, and then those devices are again capable of installing their update by their own. So by this, the advantage of E2G2C OTA updates are, this is one of the best possible architecture that allows safe and modular OTA update. It reduces the risk to the entire fleet, since each node connected to the gateway can handle their update by themselves, or the gateway can directly execute update on the edge by protecting the fleet if one or more update goes wrong in between. So the system will still be able to function with the corrupted nodes. The disadvantage is similar to G2C, which we saw earlier. E2G2C also has the same single point of failure when it comes to the failed update. In this case, the nodes may or may not be able to have the ability to let the gateway know the update status in an event of corrupted update. So thereby this can lead to the mismatch in the update schedule. As I told earlier that the downloaded firmware should be well partitioned in your firmware device. So let's consider again an example of ESP32. The ESP32 allows us to partition the device flash to multiple partition based on the available space. So this is very similar to the computer hard drive partition when you have operating systems running on the same PC. For example, one partition may run Windows OS while the other may run the Linux. So in an ESP32 module, we actually have to provide a CSV file that contains the partitions offsets and their names. So here is an example of CSV file that outlines the partition table which is needed by the ESP32 to operate with the OTA features. So you can see there are three app types. Each contains 1 MB of data. The last three rows, that is factory app, OTA 0 app, and OTA 1 app, all are of 1 MB size. So the factory app is the main firmware that will never change and it cannot be updated. This is verified application code that that the device will fall back to if there are any issues with either of the two OTA partitions, that is OTA 0 and OTA 1. Any of them fails, then factory app comes into the picture. The bootloader on the ESP32 will read the stored data in the OTA partition that you can see in the second row, OTA partition data, to see which of the three partitions is best for the app to load. Again, that is factory app or OTA 0 or OTA 1. So if the OTA data partition itself is empty, then it will boot into the factory app partition. This is why it is necessary to make sure that the factory app contains the logic to check for the new firmware update. So when we are updating our device using OTA technology, there are few best practices that is followed by the industrial professions. So what they actually follow, we can see them one by one. When designing or developing and deploying a system, the following key points are must that is to be addressed. So first is incorporating an OTA mechanism from day one. So adding OTA update routing to the firmware greatly improves the chance of introducing feature update and bug fix at later time. So this can be during the production or it can even be after the deployment of your device into the market. Next best practice is progressive development approach. So following a progressive development approach, it can not only make the development more reliable, but also streamlines the development of new features. The next, we can have a prioritized update. So to make sure that the functionality of running device is not interrupted, the update must be prioritized so that the device that are sitting idle get the update first and it is installed on them, rather than going for the device which are actually working or into some critical task. So we can avoid their update. We can put their priority at the lower side and take the idle sitting devices first. Next, we can have atomic update with rollback. So instead of pushing large update, micro update can make the update process more gradual, and the migration from the older version to the newer version can be a very swift task. Next, we can have backing up current configuration and management platform. So using a central management platform, the previous update must be logged and managed to track the changes up to the date. So after getting all the details of OTA process and its execution, its flow, its type, its method, let's discuss what are the key points to make to take care about the security of firmware update. So the key elements of a secure OTA process are: use a secure cloud service to enable a trusted notification of new firmware update to all the deployed devices. So after connecting using HTTP, you can securely update the firmware to the cloud. The next security feature we can have is the IoT device should authenticate the new firmware file to ensure that it was made by a trusted source using the code signing technique. Once code is written and it is uploaded, this file will be signed there. Next, we can have when the IoT device will download and confirm the signed file if all key matches, and then it will load the new firmware into your device. So here the Device bootloader should also perform additional steps to ensure that the image that is being loaded into is signed properly, just in case there is an injected attack which happens to your device. So bootloader is the very important part that should be taken care as a security measure. Yes, this is all for today. I hope the webinar gave you greater insights into the OTA update. I see some questions coming. We will respond to this individually via email. For any further queries, you can contact us. Details are on the screen. We would be happy to help you to implement the OTA firmware update for your products as well. And please note, a recorded version of this webinar will be available on our website in a week from now. We will also send you an email with the link on your registered email ID to access the webinar. I would like to thank you again for your time. Have a great day ahead. Thank you, guys. Thank you.